Yeah, so first I imported my libraries, pandas, matplotlib, and the scikit-learn. So then I loaded my, or in this case, I loaded the King County house data set, the house price data set directly from my local project folder. And as you can see, from this data set had output year columns. Okay, there we go, like square foot living, waterfront grade, year build, so on and so on and so on, right? And this is a better view here of the columns. All right, so next I moved to data cleaning. I focused on the three columns I needed, and in this case, hold on, where am I? Sorry, I think there we go. Yeah, so price is my target. The square feet living is the feature, and the year builds just for engineering. So I checked for like missing values and dropped any rows that were incomplete, right? As you can see over here. Mhm. Uh, then I let me make sure this is actually, you can see it properly. Yeah, so then to make sure my simple model wasn't like skewed, I just handled outliers by removing the extreme top and bottom 1% of the data for both price and square feet living. Um, Hold on, there we go. And is this even okay? There we go. Yeah, for the feature engineering, yeah, this is like for the feature engineering step. I selected square feet living as my one primary predictor. I also created a new meaningful feature as required. Yeah, it was required. I think it was required. Yeah, yeah, the meaningful feature. Um, I created a house age, right? Um, Let me see properly. Just give me a second here. Yeah, so I created a house age by subtracting uh, the year built from 2015, which is the most recent year in this data set, anyways. And you can see the new house age column right over here, right? So really, for this simple regression, I'll just stick to just square feet living. But this house age feature is now available. Now for, let me, it's lagging a little bit here. Yeah, so now for the model, I defined my feature X as square feet living in my targeted Y as price. I then use a scikit-learn string test split to create an 80/20. I saw, yeah, 80/20 split. So giving me like a separate training and testing set. And then I initialized a linear regression, right? Sure. Yeah. So I initialized the linear regression model and called the model fit on the training data to just train it. And yeah, and so after training, I evaluated the model's performance on the test set, data it has never seen before, right? Um, and my final metrics were a mean squared error of about 45.3 billion and an R squared value of 0.4275. And so these R squared value means like the model can explain about 42.75% of the difference in house prices using only like the square footage, which is a solid start, for such a simple model. I think it's a solid start. Yeah. Um, see here what we have. I'll say this for my first test case. This visualization, this scatter plot, it shows the actual prices from the test sets in blue, right? And the red line is the regression line. The model, the model, the what you know, is it's the regression line that the model learned, right? And so you can clearly see the positive relationship as like square footage goes up, the price goes up, and the line fits the data points reasonably well. Matching the 42.75 r squared. Um, for my second test case, I used the model to predict the price of two custom input values. So first, um, to predict price for a 1800 square foot house, I created a small data frame with the column name square foot living to avoid any warnings. I was actually getting warnings initially. And so the model predicts a price of about $462,000. Um, and next, I tried a larger house at 3,000 square feet. The model predicts a price of about 727,000. And yeah, so this just demonstrates that the model is working and can generate a new prediction. So I'd say, like, to recap, I created, or I've loaded, cleaned, and I engineered features from the data set, trained a simple linear regression model, and then I evaluated its performance, completing all the steps of the assignment. Um, Thank you.